Okay, today's lesson is Unit 1, Lesson 9, which is Section 1.6 out of our textbook. We're going to be discussing absolute value equations and inequalities. So, first off, let's talk about what absolute value is. Now, my classes today were able to tell me that absolute value represents the distance that a number is from 0. So we have the numbers and we have symbols. But another way that I want you to be familiar with it when you think about it is the absolute value of x is equal to a, and the only way to get rid of these absolute value signs is to, what I say, apply the definition, and that means that x equals a or x equals the opposite of a. Okay, this is another way of giving you the definition that's down here. Okay, now if you want to think about that in more concrete terms, okay, or graphically, my Algebra 2 teacher used to tell me, I really like this. The absolute value of x is equal to 3. That means that the distance between 0 and x is 3 units. So from here to here is 3 units, and from here to here is 3. And so y'all know that 3 units this way is the number 3, and 3 units that way is the number -3. So if the absolute value of x equals, let me move that up a little bit. If the absolute value of x is equal to 3, then you can see from our diagram that x will equal 3 or -3. All the negative is doing is telling us which direction of 0 that it is, okay? But the distance that x is from 0 is 3 units, either right or left. So, as we move forward that, excuse me, with that, you want to remember, okay, when solving absolute value equations, remember to isolate the absolute value before applying the definition. Okay, so what do I mean by that definition? Excuse me. By that definition, that's what I was talking about up here. So I've isolated the absolute value of x equal to something, then x equals that, or x equals the opposite of that. Okay, so we're going to go do some problems so you'll see what I mean. And I'm going to go and highlight each time. Here's the absolute value, here's the absolute value, and here's the absolute value. So as we go through, let's go back to, oh, that was different. Okay, so let's go into the absolute value of x minus 3 equals 9. So the first thing you want to do when you're doing this is to determine whether or not it's been isolated. Is the absolute value all by itself? It is, and since it's all by itself, there's nothing being added or multiplied over here, then I'm going to write it just like I see it. Oh, I'm in a line. Hold on one second. That's pretty funny. Go back to my pen. That's why it was doing that funky thing. Okay. X minus 3 equals 9. Okay. That's writing it just like you see it without the absolute value signs. Or x minus 3 equals -9. And then you solve each one. I'm going to add 3 to both sides. X equals 12. Or add 3 to both sides here. X equals -6. Now, we talked about in our classes how important it was to check. Do you have to check? No, I can't make you check. But if you get in this habit of checking, then when it comes time to the test and you check these problems, you'll know whether or not you have them right or wrong. So it's a really good habit. So most importantly about that, how do you check? And I hope y'all remember that you check by plugging into the original equation. So if I check the 12, that's going to give me the absolute value of 12 minus 3. Does that equal 9? Well, 12 minus 3 is 9, and the absolute value of 9 is 9, so we're good. And on the other side, -6 minus 3 the absolute value. Negative 6 minus 3 is negative 9. Absolute value of negative 9 is 9, so we're good to go. So we have an answer that x equals 12 or negative 12. We're good to go. All right, look at the next one. Are we in a place that our absolute value is isolated? And it is. There's nothing being added or multiplied to it. Okay? You cannot do anything. Don't touch the stuff inside until you have done this step of getting rid of your absolute value signs. Because one of the things when you have it isolated, you always want to look and see whether or not you're going to have a negative number over there. And we didn't talk about it in the beginning, but all my students did. They know the absolute value. What they remember is it's always positive. So can you have a positive number equal to negative 3? And the answer is no, you cannot. So that's the mathematical symbol for no solution. If you don't want to use that symbol when solving equations, you can just write the word no solution. All right, let's go on to the next one. The absolute value of 4 minus z minus 10 is equal to 1. Okay, is my absolute value all by itself on that side of the equation? It is not. So I'm going to move the 10 over by adding it to both sides. And when I do that, that's going to give me the absolute value of 4 minus z equals 11. Now I have it all by itself. So I'm going to apply this definition right here, which means I write it just like I see it. 4 minus z equals 11. I write the word or, and then what's on the inside equals the opposite of 11. And now I'm going to solve. So I'm going to have minus 4 on both sides here, giving me negative 7 equals negative 11. I'm going to subtract 4 over here. And that's going to give me negative z equals negative 15. And we had a discussion in class. We aren't solving for negative z, we're solving for positive c. So if we divide both of them by negative 1, then we should get z equals 7 or 15. Oh, my bad. My students aren't here to correct me. This is positive 7. Negative, it's 11 minus 4. That's my bad. 11 minus 4 is 7. Okay, so then when you multiply both sides by negative 1, so z equals negative 7 or positive 15. Okay, and just to speed it up, okay, both of those numbers do check. All right, so let's look at the next group. Solve each equation, check for extraneous solutions. Okay, all right, where are we? We're going to go do same thing. All right, so before I do that, I want to highlight. Here is my absolute. That's not highlighted. Go away. My bad. Here's my absolute value here, and here's my absolute value here. So when you're looking at those, on that first one, is the absolute value all by itself? It is, okay? And I made my students tell me, what did they notice that was different about these problems and the ones that we did up here? And they were all able to tell that these now had a variable on the other side. And that did change things up considerably. So it's by itself. Let's apply the definition. And that's going to give me 2z minus 3 equals 4z minus 1. Or 2z minus 3 equals the opposite of 4z minus 1. Okay, so the fact that I have the opposite means that I have to change the sign of both of these on that side. So if I continue, 2z minus 3 equals negative 4z plus 1. And then I'm going to add 4z to both sides. I always combine the variables on the side that'll make them positive because I don't want to deal with negative variables. So that gives me 6z minus 3 is equal to 1. And then I'm going to add 3. So I have 6z equals 4. Divide both sides by 6. And z equals 2/3. Okay, now let's go to the other one. And that gives us, I'm going to subtract 2z this time because I want my variable to be positive. So those go away, leaving me with negative 3 equals 2z minus 1. And then I'm going to add 1 to both sides. And negative 2 is equal to 2z. Divide both sides by 2. And now you know why I crossed my z's, because they look so much like a 2. So I have z equals negative 1. Okay? And I'm going to write down what you should do to check these problems. Okay? So this should be the first one with a negative 1 would be the absolute value of 2 times negative 1 minus 3. Does that equal 4 times negative 1 minus 1? Well, this in the inside becomes negative 5. This over here is negative 5. Does the absolute value of negative 5 equal negative 5? It does not, because it's always a positive number. So that is an extraneous solution. All right, let's go check this other one. In this one, I'm going to have, just to make sure I get out of the way here, let's go with the absolute value of 2. That doesn't really look like absolute value. 2 times 2/3 minus 3. Does that equal 4 times 2/3 minus 1? Okay, now you can get your handy dandy calculator and put that together. Okay, and that's going to be negative 5/3 over here. And this over here is going to be positive 5/3. Well, is the absolute value of negative 5/3 equal to 5/3? Absolutely it is. So this answer checks. And we're good to go. All right. Look at number 24. Okay, so when we did this in class, we went to the next step. So the first step was this is all by itself. This absolute value is isolated. So now I'm going to apply my definition like I did the first step here. So I'm going to write 2x plus 5 equals 3x plus 4, or 2x plus 5. So I'm not changing what's on the inside. It either equals what's on the other side, or it equals the opposite of what's on the other side. And if I have more than one term, I got to put parentheses around it. So my students work this one by itself. If you want to pause and mute, then you can, or pause, you should pause, try to work it out by yourself, and then check back and see what I'm doing. So I'm going to subtract the 2x to collect over here. And that gives me 5 equals x plus 4. And then I'm going to subtract 4. And x equals 1. And over here, I have a little extra step because of my negative. It's going to be negative 3x minus 4. And I'm going to add 3x this time because I want my x's to be positive. And that gives me 5x plus 5 equals negative 4. Take my 5 over, I have to subtract it. 5x equals negative 9. And then I divide by 5. So in case you haven't figured out, your book really likes you to get practice with fractions. So let's go check both of these. Let's go with this. So I'm going to first check 1. And that means it's going to look like this. It's going to be 2 times 1 plus 5. Does that equal 3 times 1 plus 4? Well, 2 plus 5 is 7. So is the absolute value of 7, does that equal 7? Yes, it does. All right, let's go with the other one. Let's go with this again. So this is going to be the absolute value of 2 times negative 9/5 plus 5. Does that equal 3 times negative 9/5 plus 4? Okay, and what this side is going to give me is negative 18 plus 25 is the absolute value of 7/5. Does that equal negative 7/5? Again, okay, you can do it in your head, you can put it in a calculator, but you should be putting this in your calculator, and if you're not getting it, you need to come see me so that I can help you use your calculator. Okay, these two things are not equal because an absolute value must equal a positive number, so this solution does not work, and this is the answer. All right, so if you have your note sheet and you turn it over, we are now going to talk about inequalities. Okay, an absolute value inequality can be written as a compound inequality without absolute value signs, symbols, however you want to call it. All right? Now, the point of that, if you remember the last time that we met, we talked about what a compound inequality was. And it was an inequality, it was two inequalities joined by the word and or. Okay? And the other thing that we talked about, okay, or let's look at this. So this concept summary that we have, the first one is what we just talked about. The absolute value of x equals a. That is the distance from 0, x to 0. Okay, and the graph of it is just two dots. X equals a or x equals negative a. We talked about what this shape was. What is this shape? Okay, and y'all know that this is you told me on the last time we met, this is a segment. And these are rays. And you knew that the rays went with which of these two keywords? Everybody knew it was with the or, which means that the segment is with the and. Okay? And so in keeping with our theme of R, rays start with the letter R, or has R in it. Which one of these is going to be greater than or less than? Well, this is the greater than. It has the R. This is the less than. Absolute value of x is less than a, or less than or equal to. Absolute value of x is greater than or equal to a. Okay, so one of the things I want you to notice, okay, it says the absolute value of x is less than a. And as I said, whenever we take it away, we always write it exactly like we see it on the original one. Okay, x is greater than a. I write x is greater than a. Then, when we had the equal to, we just said, x equals a or x equals negative a. Well, there's a little difference when we have the inequality, and that is when you put the negative a on here, you had to flip the sign. So if x is less than a and x is greater than negative a, if x is greater than a, then x is less than negative a. That's how we get the two rays or the segment. And the segment, or the and statement, is the only one that can also be written like that. It has the less than symbols, just like your absolute value. These numbers are in order on the number line, just like we have. So let's look at a few of these. And like I said, never a dull moment. They're going to let you do some more fractions, so make sure you have that handy dandy calculator with you. All right, so before I go on, I need to be on, yep, I'm in the highlighter. Here is my absolute value, here and here. And so, let's go and solve it. Do I have this absolute value isolated? And I hope you said no, because I'm multiplying by 3 and I'm adding 9 on that same side. So I got to get rid of the 9 first. So we subtract 9, and that's going to give me 3 times the absolute value of 5t minus 1 is less than or equal to 14, because 23 minus 9 is 14. And then we divide by 3, and I'm writing this down because I want you to see we're dividing by a number. Do I need to flip the sign? And I hope you said no, because I divided by a positive number. So the absolute value of 5t minus 1 is less than or equal to, and don't pick up your calculator, just write 14/3. You're good to go. All right, so now this is the point where I want you to pause. Absolute value less than a number. So without looking up top, I hope you know less than, remember we just talked about, is an and statement. And our graph should look something like that. Okay, so as we keep going, to get rid of it, you write it just like you see it. 5t minus 1 less than or equal to 14 thirds. Well, I don't know why you did that. Go away. There you go. 14 thirds. So that's exactly the way we see it without the absolute value. It's an and statement, so sometimes it's easiest just to go put that and write negative 14 thirds. Okay? Now, I don't know how much practice y'all have had with solving these, but this is, a compact way of writing the three equations. So if you just jot these down, you'll see whatever you do to one part, you have to do to the other two parts also. So if I'm trying to isolate 5t, I'm going to first add 1. And 1, if I'm adding fractions, I want to write that in terms of a fraction. So how many thirds are in a whole? 3 thirds. So we're going to add 3 thirds. And if you don't want to write that, just put plus 1 and go use your calculator. That works also. Okay, so these two cancel, leaving me with 5t. My sign didn't change. I didn't multiply or divide by anything. 14 thirds plus 3 thirds, 17 thirds. Negative 14 thirds plus 3 thirds is negative 11 thirds. Okay, and so here, normally you would divide by 5, but because I have fractions, instead of dividing by 5, I'm actually going to multiply by 1/5. So you'll see that, yes, I have t. Now, easy to multiply. You just multiply straight across. So that's 17 over 15. And when you do the same thing on this side, I'm going to have negative 11 over 15. And this, come on. Come on. Nope, don't want to work. Let's try this. There we go. Is negative 11 fifteenths to 17 fifteenths. So that's the algebraic solution. To go graph it on our number line, I'm going to put 0. And on the left, I'm going to put negative 11 over 15. Okay, why are you doing that? Come back. There we go. And then over here, I'm going to put 17 over 15. I'm going to put circles on both. It's equal to, so I'm going to color them both in. And if I have this statement, I know I'm shading in between, which is what we said we were going to get in the beginning. Move that down a little bit. Okay, so there's the graph of our solution, our algebraic solution right here. Okay, let's go look at number 34. So to do number 34, is it isolated? It is isolated. It's a greater than. But before you stop and say, oh, that's an or statement, okay, notice again, what do you see here? Okay, that's a negative number. And believe it or not, all my classes said, oh, that means no solution. It doesn't mean no solution every time. Remember, this is a positive number. And every positive number is greater than a negative number. So that means what values can I put in for it? Well, any number that I put in here is going to be positive. So what that is what we say, all real numbers. That's a cursive R. Or you can write it that kind of R if you like. Or you can say all real numbers. Because anything I put in there for x, when I take the absolute value of it, it's going to be positive, and that will be greater than negative 9. So when you have a negative number over there, you got to pay attention. If it's greater than, it's all real numbers. If it's less than, it's going to be no solution. How do you graph all real numbers? Put a 0 on your number line. You would leave it like that if it was no solution. But since it's all real numbers, it's everything on that number line. So I'm going to put an arrow on both ends because I'm telling you that I know it goes on forever and ever. And then I shade everything in between. So that's the graph of all real numbers. All right, so the last type of problem that I want to do is one where you're going backwards. I like these problems. Okay? Write each compound inequality as an absolute value. So here's a compound, which is similar to what we have there, and we're going to write an absolute value. So the first thing is the absolute value less than or greater than? Boom, everybody knew it was less than. We got a variable that's b, and it's going to be the distance from b in some number. So I find these easiest to do by making a graph, 50, 55, okay? And you got to understand is the distance between b, because this is b and this is b, the distance between those numbers has to be the same. So that has to be the same number as this, which means this has to be in the middle. So what's halfway between 50 and 55 is 52.5. So this midpoint or middle number will always be inside with your absolute value. That says the distance between b and 52.5 is less than or equal to, well, what's the distance between 52.5 and 50? 2.5. So that's all it is. Okay? Let's do another one of those because I know you think they're so much fun. Okay? Look at this one. Actually, before I graph, let's go do absolute value. Again, the only way to write that is if it's less than or equal to. I have a D minus something. And I have a number, 0.1187 and 0.1190. And I know this is D and this is D, but I have to find that middle point because the distance between this number and D has to be the same. So what is this number? Well, if you notice the ones are the same, so really all you're looking at is 87 and 90. And my people didn't have any trouble telling me that the middle number between that is 88.5, but that decimal's right there. So I'm going to have 0.11885. By the way, if you don't know how to figure that out, I've been doing it mentally, but you can always add the two numbers and divide by 2. Add these two numbers and divide by 2, and you'll get that number right there. Okay? And the other number, as you can see back over here, this is the number that's 2.5. Okay, that distance between the middle and the end. So what is our number over here? Well, if you subtract those, you will get 0.00015. So that is this number. And that's how you can write that statement in a more compact form. Okay, so the other one I did in class, I did want to talk about because I felt like after doing this multiple times that I did a lot of examples with less than, but not too many with a greater than. So I wanted to do one more, and I just chose this one because it was a simple one. You know how to isolate the variable. Once you have that variable isolated, okay, then you need to apply the definition. So to apply the definition to this right here, you always, oh poo, my bad, go back to the pen. Yoo-hoo. Okay, you always write it like you see it. X minus 5 is greater than or equal to 8. That's exactly like I see it without the absolute value signs. Greater than means or, and then x minus 5 is less than or equal to negative 8. So you have to flip it, okay, and then change the sign of it. So that's your next step. So you should be able to do these without any trouble. And like I said, I didn't feel like we did enough of those, so I wanted to do one more example. If you have any questions, please don't hesitate to come see me or email me. Thank you very much.